Hey guys, welcome to Mathletics. Today I'm going to talk about separable differential equations. So a separable differential equation is a type of first order differential equation. If a first order differential equation of this form, y prime minus f of ty is equal to 0, can be written as y prime minus b of t times c of y is equal to 0, we say that it is a separable differential equation. Or in other words, if we can separate this function into two expressions, each dealing with either t or y or whatever variable you have, then it's separable. So we're going to separate the expression into two expressions, each dealing with one variable only, and we will integrate. So we have y prime, which is also dy over dt, and we said it's equal to b of t times c of y. I just took all of this here. So if we move c of y to the left and dt to the right of the equation, what do we get? We will get dy over c of y is equal to b of t times dt. Now notice that this fellow deals only with y, and this part deals only with t. We have separated the equation. Now we will take both sides as individual integrals, and we should be able to solve the equation fairly easily. What I mean is, we will integrate both sides, dy over c of y, and we will equate. Now when you integrate, you can add the all-important plus c to either side, this or this, it does not matter. So let's see this business with an example. Let's say we have dy over dt is equal to y cubed times 1 plus t squared. Just as I said above, we will try to separate this expression into just y and just t. So if we just take y cubed, that's just y, and 1 plus t squared, that's just t. Notice that 1 can be just written as 1 times t to the 0, so it's also t. So if we take these two expressions, they're separate, as in they deal with only y or only t. So if I move y cubed over here and d of t and dt over here, I get dy over y cubed is equal to 1 plus t squared times dt. Now I will integrate these separately. So for this one, I have integral dy over y cubed, which is the same as the integral of y to the negative 3 dy, and this is negative 1 over 2 y to the negative 2. We will hold plus c for now. For this, we have the integral 1 plus t squared times dt, and this is equal to t plus t cubed over 3. Put them together, as in equate them, and add a constant. So you have negative 1 over 2 y to the negative 2 is equal to t plus t cubed over 3 plus c. We are basically done. You don't need to solve for y because that can be pretty complicated and it's unnecessary. You can just leave the answer like this. But if you do want to solve it, you should get something like y is equal to plus or minus square root of negative 3 all over 2 3x plus x cubed plus c. Let me know in the comments if you get something different. Let's do one more example. Let's say we have 2 times dy over dt is plus y to the 4 times sine t is equal to 0. We have to play with this a little bit to bring it in the form that we were dealing with. Now we are dealing with something that has this form. So the first order of business is the coefficient of this should be 1. And we have been dealing with y prime is equal to something, something, something. So let's see that something, something. So we have 2 dy over dt is equal to negative y to the 4 sine t. Just move this here. Now if you divide everything by 2, you get dy over dt is equal to negative 1 over 2 y to the 4 sine t. And we are back in business. As before, we're going to take these integrals, but before that, we will separate. So this dt, we'll send it here. And this y to the 4, we will send it here. So we get dy over y4 is equal to negative 1 over 2 sine t dt. Now we will integrate these separately. First one, we have dy over y to the 4, which is equal to the integral of y to the negative 4 dy, which is negative 1 over 3 y to the negative 3. For our friend right here, we have the integral of negative 1 over 2 sine t dt, which is 1 over 2 cosine t. Equating these, we have negative 1 over 3 y to the negative 3 is equal to 1 over 2 cosine t, and we add a constant of integration. What if we had initial conditions? We can then solve for c. Let y0 is equal to 0, as in whenever we put in 0 for t, our y comes out to be 0 when we have this expression in terms of y. So if I had this expression as y is equal to something something, and this something something was in terms of t, then whenever I would put 0 for t, this fellow would come out to be 0 as well. That is what this means. So we can actually use this without really doing this. So all we have to do is put in 0 for wherever we see t. And because this expression comes out to be 0, whenever you see y, put 0. So you have negative 1 over 3. 0 times negative 3 is equal to 1 over 2 cosine 0 plus c. This is just 0. And this fellow is 1. So we have 0 is equal to 1 over 2 plus c. So our c is negative 1 over 2. So if we put in our c for here, our final answer becomes negative 1 over 3 y to the negative 3 is equal to 1 over 2 cosine t negative 1 over 2. And this is our final answer. Let me give you guys a shortcut of method. Not a shortcut, but just a method. But because we're cool, we're going to call it the shortcut. First, you check if the equation can be of form y prime is equal to b of t times c of y. 2, you make both sides only in t and only in y, or any variable that you're dealing with. 3, you integrate separately and equate. And lastly, you add your plus c, or you solve it if you have some given conditions. So I hope this shortcut will be able to help you guys, and if you guys enjoyed the video and understood and the examples helped a little bit, do share this with your friends, and I will see you guys very soon.